In this video, we will be covering 10 geometry, chapter number 1 similarity, problem set 1, question number 1. So first question it is, select the appropriate alternative and in triangle ABC and triangle PQR in a 1-to-1 correspondence. So AB upon QR is equal to BC upon PR is equal to CA upon PQ. So we have to select one of the alternates. So here in question it is given AB. Okay, first I am writing only numerator. AB is equal to BC is equal to CA. Yes, so below it was here given QR, so I can write here Q and R. So for instance I can just correspond that A corresponds to Q and B corresponds to R. So next it is written as PR. Yes, but here already we had written B corresponds to R, so we will write first R, then we will write as P. Next it is with CA it is written PQ. Yes, PQ. So C we had correspond to P. Yes, so here we will write as P and Q. So togetherly we can write as A, B, C, and here together if we write it is Q, R and P. Yes, so we have to find the correct answer. So if we check this A, B, C, okay, so A, B, C, and with A it should be Q, with B it should be R, and with C it should be P. So A and Q first we'll check. Where is A? See here in this part A second position, so Q is also in second position. Next B should be corresponding to R, so here see third position B and in third position it is R, and C with P, so C is in the first position and P is also in the first position. So this is our answer, that is triangle PQR is similar to triangle CAB. Question number 2. So in this question, it is given in triangle ADEF and triangle PQR, DE is congruent to Q. See here, this is your D. We can take it as 1 and it is congruent to Q. Yes, so this I'll take it as 1. Next, it is given R is congruent to E. So here R is congruent to E. So for both this, I'll take it as 2. And the remaining is F, so this I'll take it as 3 and here also I'll write it as 3. So together I'll write, so together if we write like this D E F, and here I can write as Q R P. So see the first option EF upon PR, EF and PR, yes it is right, and DF first third is equal to PQ, so this is true. So next for first one it is true. So second question DEF, that means second option QRP. So DE upon PQ, DE first second and PQ, okay, PQ it is not coming first second option, so this is false. Yes, or false option is B. Question number 3. In triangle ABC and triangle DEF, angle B is congruent to angle E and angle F is congruent to angle C. So here side AB is equal to 3 times of DE. Yes or no? So here AB upon DE will be equal to 3 upon 1. That means the sides are in ratio. Yes, and not congruent. Therefore, the correct option will be the triangles are similar but not congruent. in triangle ABC and triangle DEF, both are equilateral triangles. And here given is area of triangle ABC is to area of triangle DEF is equal to 1:2. Yes. So I'll write like this: area of triangle ABC upon area of triangle DEF is equal to 1/2. Yes, already both the triangles are equilateral triangle. That means triangle ABC and triangle DEF are equilateral triangles. Therefore, triangle ABC and triangle DEF are similar. Yes, if both the triangles are similar, by ratio of areas of two similar triangles, we will get area of triangle ABC upon area of triangle DEF is equal to, from three side we will take which side? We'll take it as AB. Why? Because in question the value of AB is given and we have to find the length of DE. So we can write AB square upon DE square. Okay. So area of triangle ABC and area of triangle DF in question already it is given, it is 1:2, and we had written here also. Here we can write as given. So 1/2 is equal to, the value of AB is 4. So I can write here 4 square upon DE square. Therefore cross multiply, 1 into DE square is equal to 4 square into 2. Therefore 1 into DE square is, DE square is equal to 16 into 2. Taking square root, we will get DE is equal to root of 16 into 2. That is, the root of 16 is 4 and inside it will remain as 4 root 2 units. Yes. So from the given option, we are getting option number D as the correct answer. In the figure, it is given XY is parallel to BC. That means this is XY and this is BC. So XY is parallel to BC. Then which of the following statement is true? So in triangle ABC, seg XY is parallel to seg BC. Yes, if it is parallel, we can use the theorem, basic proportionality theorem. So by basic proportionality theorem, we will get AX upon XB is equal to AY upon YC. So by invertendo, we will apply invertendo. So we will get XB upon AX is equal to YC upon AY. After this, we will apply componendo. So by componendo, what is componendo? We have to add the denominator to the numerator. So XB plus AX upon AX is equal to YC plus AY upon AY. So XB plus AX, if we see in the figure, XB plus AX, it is AB. AB upon AX is equal to YC plus AY. See here it is YC and here it is AY. So YC plus AY will be equal to AC upon AY. Yes. So in the question, then again we can apply by alternando. Yes or no? What is alternando? We can write numerator upon numerator is equal to denominator upon denominator. So I can write here ax upon ay. That means ax upon ay is equal to AB upon AC. Yes, so this answer we can find it in option number 1, that is A. AB upon AC is equal to AX upon AY.
Question number 2. In triangle ABC, B dash D dash C and BD is equal to 7. So we can write here BD as 7. Next is the value of BC is 20. So we can write here as 20 for BC. Then find the following ratios. So the first one will solve, that is area of triangle ABD and triangle ADC. Solution. So first we'll just check it out which are the triangles. ABD is this triangle from the figure, and next triangle is ADC. That means ADC, this triangle, right? So that means first triangle is this part and the second triangle is this part, right? Now students, just check it clearly that whenever there is a common vertex, right, for both the triangles, whenever there is a common vertex for both the triangle and the opposite side or the base is in a straight line, then these type of triangles will be having a common height, right? So we'll write this in solution. Right now here in this figure, triangle ABD and triangle ADC have a common vertex A. Therefore, they have equal heights. Now the statement is triangles with equal heights have areas proportional to their corresponding bases, right? Therefore, area of triangle ABD upon area of triangle ADC. Now from the figure, area of triangle ABD is having base as BD, right? So we can write here as BD, and area of triangle ADC is having base as DC, right? So we can write here as DC. So the value of BD we know it is 7, but the value of DC we do not know, right? So before starting this sum, we have to write here as in triangle ABC, B dash D dash C, right? Therefore, BC will be equal to BD plus DC. So the value for BD is 7, value for BC is 20 plus DC. Therefore, DC will be equal to 20 minus 7, that is equal to 13. So the value for DC is equal to 13. Now we will substitute the value. So the value of BD is 7 and the value for DC is 13. So our final answer is area of triangle ABD upon area of triangle ADC, it is equal to 7 upon 13. Now second question, that is area of triangle ABD and triangle ABC. We'll check out in the figure which are the triangles. Now area of triangle ABD, this triangle, and ABC, that means full bigger triangle ABC, Okay, now we'll move on with this solution. Now triangle ABD and triangle ABC have a common vertex A. Therefore, their heights are equal. Now, triangles with equal heights have areas proportional to their corresponding bases. Therefore, area of triangle ABD upon area of triangle ABC will be equal to. Now, area of triangle ABD is having base as BD, right? So we can write here as BD. Area of triangle ABC is having base as BC. So we can write BC. But in the given question, the values are given, right? So the value for BD is 7. So we can write here 7, and the value for BC it is given as 20. So we can write 20. Therefore, the final answer is area of triangle ABD upon area of triangle ABC will be equal to 7 upon 20. So this is our final answer. Now we will move on with the third part, that is area of triangle ADC and triangle ABC. Now first we'll check out from the figure. This is triangle ADC, right? And next is area of triangle ABC, that means the full triangle ABC. Okay, so we'll write this solution. Triangle ADC and triangle ABC have a common vertex A. Therefore, their heights are equal. Now, triangles with equal heights have areas proportional to their corresponding bases, right? Now, therefore, area of triangle ADC upon area of triangle ABC, right? Now, area of triangle ADC is having base as DC, right? So we can write here as DC, and area of triangle ABC is having base as BC. So we can write here BC, but the values are given in the question, so we need to substitute the given values. So the value for DC from here we already got, it is as 13, and the value of BC it is there in the question, that is 20, right? So we can write here as 20. So the final answer we can write area of triangle ADC upon area of triangle ABC will be equal to 13 upon 20. The ratio of areas of two triangles with equal heights is 2:3. If base of the smaller triangle is 6 cm, then what is the corresponding base of the smaller triangle? So solution will write. Now here two triangles are given. So let A1 be the smaller triangle and A2 be the bigger triangle. Now, here ratio of areas of two triangles with equal heights is 2 is to 3. That means A1 is to A2, it is given 2 is to 3. Now, if the base of the smaller triangle is 6, so smaller means the first triangle we had taken as smaller, right? So, B1 we can write as 6 centimeter. So what is the corresponding base of the bigger triangle? So B2 is equal to question mark. So we know the statement, triangles with equal heights have areas proportional to their corresponding bases, right? Therefore, A1 upon A2 will be equal to B1 upon B2. So A1 upon A2 value we already know, that is 2 upon 3. The value for B1 is 6. So value for B2 we do not know, right? So we'll cross multiply. Therefore B2 is equal to 3 into 6 upon 2. Therefore 2 ones are 2, 2 threes are 6. B2 is equal to 3 threes are 9, right? So base of the bigger triangle is 9 centimeter. Question number 4. In the figure, angle ABC is equal to angle DCB is equal to 90 degree. The value for AB is 6, value for DC is 8. We need to find area of triangle ABC upon area of triangle DCB. So we'll check out which are the triangles ABC. That means this triangle ABC, and the next triangle is DCB. That is DCB, right? So first we'll check out the figure, that both the triangles are having a common base BC, yes or no, right? So these two triangles will be having areas equal to their corresponding heights. Now this same thing we will be writing it in the solution. So in solution we can write triangle ABC and triangle DCB have a common base BC. Therefore, triangles with equal bases have areas proportional to their corresponding heights. Therefore, area of triangle ABC upon area of triangle DCB will be equal to, now ABC is having base heights as AB, right? So we can write height as AB, and area of triangle DCB is having height as DC. So we can write here as DC. But we also need to substitute their values. That means the value of AB, it is given in the question as 6. So we can write 6, and for DC the value is 8. So we can write as 8. So 2 3s are 2 4s are. So the final answer we can write area of triangle ABC upon area of triangle DCB is equal to 3 upon 4. Problem set 1, question number 5. Now, here in the given question, it is given the value for PM, it is 10, right? So here PM, it is 10 centimeter. Next is area of triangle PQS is 100. So this full area, it is 100 square centimeter, and QRS, this full area, it is 110 square centimeter. Now solution. First we'll move on with area of triangle PQS. So in triangle PQS, area of triangle PQS is equal to half into base into height. Now we know what is base. Base is QS. Height is PM. And area also we already know, right? We'll write the value of area, it is 100 is equal to half into value of QS. We don't know the value of PM, it is 10. Therefore, the value of QS is equal to 100 into 2 upon 10. 0, 0 cancel. Therefore, the value for QS is 10 to the 20 centimeter. Right? Now, next is in triangle RQS. So area of triangle RQS is equal to half into base into height. So here base is QS and height is NR. So area of triangle RQS, it is already given 110 is equal to half into QS. So the value for QS we already got it from here, that is 20, into NR. The value for NR we need to find. Therefore NR is equal to 110 into 2 upon 20. 0, 0 cancel, 2, 2 cancel. Therefore the value for NR is equal to 11 centimeter. Problem set 1, question number 6. Triangle MNT is similar to triangle QRS. Length of altitude drawn from point T is 5 and length of altitude drawn from point S is 9. So find the ratio of area of triangle MNT upon area of triangle QRS. So we will first make the diagram. So this is triangle MNT. MNT, and the next triangle is QRS. That means QRS. So in the given question, it is given length of the altitude drawn from point T. So from T we'll make altitude, and the length of altitude drawn from point S. So from S we'll make an altitude, right? So its value is given that the length of the altitude, suppose its name we can give as A and here as B. So TA value is 5 and the length of altitude from point S is 9. So the value for SB is 9. Solution. First of all, in the given question, it is given triangle M and T is similar to triangle QRS. TA is equal to 5 units. The value for SB, it is 9 units. Right? Now, we already know that if the two triangles are similar, then it is equal to the square of its corresponding sides. But here the value of side is not given, right? So, but in the theorem, we had seen that side is equal to altitude. Yes, students. So, in place of side, we can use altitude, right? So, we can write as if two triangles are similar, then ratio of areas is equal to their squares of their corresponding altitudes. Here we can write the. So I am reading it again. If two triangles are similar, then ratio of areas is equal to the squares of their corresponding altitudes. So we can write as area of triangle MNT upon area of triangle QRS is equal to. Now for the first triangle MNT, altitude is TA, so we can write TA square upon SB square. So the value for TA is 5, that is 5 square upon 9 square. Its value is 25 upon 81. So final answer we can write as area of triangle MNT upon area of triangle QRS is equal to 25 upon 81. In the figure ADC, BEC, sec DE is parallel to AB. That means this DC is parallel to AB. Now the value for AB is 5, DC is equal to 3, BC is equal to 6.4. Total BC it is equal to 6.4. So we have taken here the value of BE as X. So the remaining value will be 6.4 minus X. Now we'll write solution. Now in triangle CAB, DE is parallel to AB. Therefore, as we studied in basic proportionality theorem, we have to write the statements. So, by basic proportionality theorem, CD upon DA. See from the diagram, CD upon DA should be equal to CE upon EB. So this is equal to CE upon BE. So the value for CD it is 3, DA it is 5, CE it is 6.4 minus X upon X. So after that we'll just cross multiply. Therefore we'll get 3x is equal to 5 into 6.4 minus x. Therefore 3x is equal to, now 6.4 into 5. 5 4s are 20, 5 6 are 30, 31, 32. That means 32 minus 5x. Now 3x, 5x will come to the left hand side and this is equal to 32. Therefore 3x plus 5x it is 8x is equal to 32. Therefore x is equal to 32 upon 8. 8 fours are 32. Now in the question we can check, we need to find the value of BE, right? And the value for BE we had taken as x. So BE is equal to 4. Now in the question there is no units given, so we will write 4 units.
Question number 8. In the figure 1.76, sec PA, sec QB, sec RC and sec SD are perpendicular to line AD. So the value of AB it is 60. BC value it is given as 70. Next CD it is given as 80. Now given we'll write first sec PA, sec QB, seg RC and seg SD are perpendicular to line AD. The values given are AB it is equal to 60, BC it is equal to 70, CD is equal to 80, PS
it is equal to 280. Now to find, what we need to find here is PQ, QR and RS. Now solution or proof. First of all, in question it is given seg PA is perpendicular to line AD. Next, seg QB is perpendicular to line AD. Seg RC is perpendicular to line AD. Also seg SD is perpendicular to line AD. Now students, अगर हर एक लाइन परपेंडिकुलर है, राइट, देन बाय करस्पॉन्डिंग एंगल्स ये सभी लाइन क्या हो जाएगा, पैरेलल हो जाएगा. ऑल द लाइन्स विल बी पैरेलल. सो वी कैन राइट देयरफॉर seg SD is parallel to seg RC is parallel to seg QB is parallel to seg PA. Reason we can write corresponding angles. Okay. Now first we'll move on with the first three sides. That means seg SD is parallel to seg RC is parallel to seg QB. Right. If all the three sides are parallel, then by property of intercepts made by three parallel lines, what we will get? See here, same as BPT, SR upon RQ will be equal to DC upon CB. So we can write SR upon RQ is equal to DC upon CB. Now by alternando we can write SR upon DC, it is equal to RQ upon CB. So this we can take as equation number 1. Next we will take seg RC is parallel to seg QB is parallel to seg PA. Therefore, by same property, by property of intercepts made by three parallel lines, what we will get? We will get RQ upon QP, it is equal to BC upon BA. Therefore, by alternando, we will get RQ upon BC, it is equal to QP upon BA. Now this we can take as equation number 2, right? Now from 1 and 2, what we will get? From 1 and 2, this is second. So from equation 1 and 2, we will get SR upon DC is equal to RQ upon CB, it is equal to QP upon BA. Now students, we had learned in 9th standard in ratio and proportion chapter. So by theorem on equal ratios, we will get each ratio is equal to, we can add up. Yes or no? Theorem on equal ratios में हमने यही सीखा है, ratios को हम add करें या subtract करें तो आंसर, रेशियो का आंसर भी सेम होगा. So that means SR plus RQ plus QP upon DC plus CB plus BA. Now इसको आगे बैठाएंगे. So SR plus RQ plus QP, from the figure you all will get value as PS,
एंड डीसी का वैल्यू इट इज 80, CB का वैल्यू इट इज 70 एंड BA का वैल्यू इट इज 60. The value of PS it is 280 upon 210. So we'll just cancel it. 7 4s are 7 3s are. So its answer is 4 upon 3. That means हर एक रेशियो का वैल्यू क्या है 4 upon 3. That is हम लोग लिखेंगे SR upon DC का भी वैल्यू होगा 4 upon 3. नेक्स्ट RQ अपॉन CB का भी वैल्यू 4 अपॉन 3 है. नेक्स्ट QP अपॉन BA का भी वैल्यू क्या है 4 अपॉन 3. नाउ क्रॉस मल्टीप्लाई करेंगे, बट बिफोर क्रॉस मल्टीप्लाई वी नो द वैल्यू ऑफ DC, CB एंड BA, राइट. तो इनका वैल्यू हम लोग क्या करेंगे सब्स्टिट्यूट करेंगे. सो देयरफॉर SR अपॉन DC का वैल्यू इट इज 80, इट इज इक्वल टू 4 अपॉन 3. RQ अपॉन CB का वैल्यू इट इज 70, इट इज इक्वल टू 4 अपॉन 3. QP अपॉन BA का वैल्यू इट इज 60, इट इज इक्वल टू 4 अपॉन 3. अभी हम लोग क्रॉस मल्टीप्लाई करेंगे. देयरफॉर SR इज इक्वल टू 80 इंटू 4 अपॉन 3, कॉमा RQ इज इक्वल टू 70 इंटू 4 अपॉन 3, कॉमा QP इज इक्वल टू 60 इंटू 4 अपॉन 3. नाउ ये पहला वाला पार्ट SR का वैल्यू में कोई भी कैंसिलेशन नहीं हो रहा है, राइट. सो वी विल राइट एज इट इज बाय मल्टीप्लाइंग. द वैल्यू ऑफ SR इज 84 320 अपॉन 4, कॉमा RQ का वैल्यू इट इज 7 4 28 280 अपॉन 3, कॉमा QP का वैल्यू इट इज 60. यहाँ कैंसिलेशन हो रहा है, राइट. तो 3 1 3 3 20 so 24 it is 80. So this is our final answer.
In triangle PQR, sec PM is a median. Angle bisectors of angle PMQ and angle PMR intersect side PQ and side PR in points X and Y respectively. Prove that XY is parallel to QR. Complete the following by filling in the boxes. Now in triangle PQM, we can see this triangle PQM. Here MX is the bisector, right. Now हमने ऑलरेडी प्रॉपर्टी ऑफ एंगल बाइसेक्टर में सीखा. सपोज ये ABC है, ये मीडियन है, ठीक है. मीडियन क्या काम करता है, बेस को दो पार्ट में डिवाइड करता है, राइट. सो प्रॉपर्टी ऑफ एंगल बाइसेक्टर थ्योरम में ये घर जैसा दिख रहा है, ये पिलर है, ये AB और AC छपरा है, राइट. तो एंगल बाइसेक्टर थ्योरम में क्या देखने को मिलता है, AB छपरा अपॉन छपरा इज इक्वल टू बेस BD अपॉन बेस सेकेंड बेस DC. सपोज हम लोग AB से स्टार्ट करता है, दिस इज अ फर्स्ट पार्ट इफ यू आर टेकिंग, तो बेस भी BD से ही लेना पड़ेगा, राइट. सो यहां MX इज द बाइसेक्टर, राइट. MX अगर बाइसेक्टर है तो हम लिख सकते हैं यहां PM अपॉन MQ, ये दो छपरा आएगा, राइट. PM अपॉन MQ. अभी PM ऊपर से लिया है तो बेस भी PX अपॉन XQ, ठीक है. सेम वे राइट हैंड साइड में, नाउ दिस आई एम रबिंग, या राइट हैंड साइड में दिस ट्राइंगल. सो MY क्या है, बाइसेक्टर है. सो वी कैन राइट PM अपॉन MR, इट इज इक्वल टू PY अपॉन YR. ये PY अपॉन YR, ठीक है. बट LHS देख, इफ वी सी इन द LHS न्यूमरेटर इज सेम बट डिनोमिनेटर अलग है, MQ और MR. डायग्राम में अगर देखें तो PM मीडियन है, PM अगर मीडियन है तो ये दोनों बेस क्या होगा, इक्वल होगा. सो सेम चीज यहां लिखा हुआ है कि MQ इज इक्वल टू MR, राइट. तो दैट मीन्स डिनोमिनेटर भी इसका क्या है, सेम है. इफ द LHS इज सेम देन RHS also becomes equal, right. So we'll get PX upon XQ is equal to PY upon YR. So अगर ट्राइंगल में जरा देखेंगे, क्या है, पी एक्स अपॉन एक्स क्यू इज इक्वल टू पी वाई अपॉन वाई आर. सो साइड्स आर इक्वल, देयरफॉर एक्स वाई क्या होगा, पैरेलल होगा क्यू आर के साथ. रीजन इज कन्वर्स ऑफ बेसिक प्रोपोर्शनैलिटी थियरम.
Question number 10. In figure 1.78, bisectors of angle B and angle C of triangle ABC intersect each other in point X. Line AX intersects side BC in point Y. AB is equal to 5. So I can write here AB is equal to 5. AC is 4 and BC total it is 6. So then find AX upon XY. Now first we will be writing given. Given is bisectors of angle B and angle C of triangle ABC intersect each other in point X. Next it is given line AX intersects side BC in point Y. Now values given are AB is equal to 5, AC is equal to 4 and BC is equal to 6 units. What we need to find here is, हमको क्या find करना है? We have to find AX upon XY. Now first we will take this triangle AYB. Now in triangle AYB, ray BX is the bisector of angle ABY. Therefore, by property of angle bisector theorem, what we will get? AB upon BY, it is equal to AX upon XY. This we can take as equation number 1. Similarly, in the right hand side, in triangle AYC, ray CY, not CY, CX is the bisector of angle ACY. Therefore, same property, by property of angle bisector theorem, what we will get? AC upon CY is equal to AX upon XY. This is equation number 1 and equation number 2. So now from 1 and 2 we can write AX upon XY, it is equal to AB upon BY, it is equal to AC upon CY. Now we can take theorem on equal ratios. By theorem on equal ratios, what we will get? X upon XY, it is equal to AB plus AC upon BY plus CY, right? Now we'll check whose value is given. AB value is 5, AC is 4. So we can write 5 plus 4 upon BY plus YC. BY plus YC, it is BC. So 5 plus 4 and BC value it is 6. 5 plus 4 it is 9 upon 6. 3 3s are 3 2s are. So final answer we can write AX upon XY it is equal to 3 upon 2.
In quadrilateral ABCD, seg AD is parallel to BC. So this AD is parallel to BC. Diagonal AC and diagonal BD intersect each other in point P. Then show that AP upon PD is equal to PC upon BP. Solution. In question it is given in quadrilateral ABCD, seg AD is parallel to seg BC, right? So if it is parallel, then alternate angles will be congruent, right? So therefore we can write, therefore angle ADB is congruent to angle CBD, but we have to use this in triangle, right? So we can write as angle ADP. Instead of B we can write P is congruent to angle CBP. So this is alternate angles, right? So reason alternate angles, and this we can write as equation number 1. Now we'll move on with the triangle. So we'll write the triangle name in 1-to-1 correspondence, that is in triangle ADP and triangle C, B is your alternate angle and P is your vertically opposite. Therefore, angle ADP is congruent to angle CBP. Reason from 1. Next, angle P is this one, right? So, angle DPA is congruent to angle BPC. Reason vertically opposite angles. Therefore, triangle ADP is similar to triangle CBP by AA test for similarity. Now we'll write upon form, that is AD upon CB is equal to DP upon BP is equal to AP upon CP. Reason is corresponding sides of similar triangles. Now here we can check in the question AP, yes this is AP, then PD, right? PD is here DP, then PC BP, PC and BP. That means we don't need this ratio, right? So right now we'll move on further. Therefore we can write as DP upon BP is equal to AP upon CP, right? But we need is AP upon PD, right? Numerator upon numerator and denominator upon denominator. That means we can use alternando. By alternando we get AP upon PD is equal to PC upon BP, right? So hence proved.
Question number 12. In figure 1.80, xy is parallel to AC. If 2 into ax is equal to 3bx and xy is equal to 9, complete the activity to find the value of AC. Now, 2 into ax is equal to 3bx. It is given in the question. So, we are taking bx to the left hand side because it is getting multiplied. तो left hand side में जाकर divide होगा. And 2 multiply हो रहा है right hand side में जाके क्या होगा? Divide होगा. So, this is 3 upon 2. Now, componendo करेंगे. What is componendo? Denominator gets added to the numerator. That means ax plus bx upon bx. It is equal to 3 plus 2 upon 2. 3 plus 2 it is 5 upon 2. Now we'll take triangle BCA is similar to triangle. Now see here BCA. B full triangle, BCA full triangle and BYX this small triangle. Both are similar by AA test. Why AA test? Because these two are parallel, right? Parallel है तो दोनों corresponding angles हम लोग लेंगे, right? Therefore both the triangles are similar by AA test. बट बी ए अपॉन बी एक्स का वैल्यू यहाँ पे मिला है ऑलरेडी, इट इज 5/2, इट इज इक्वल टू ए सी अपॉन एक्स वाई। ना क्रॉस मल्टीप्लाई करेंगे तो ए सी इट इज इक्वल टू 5 into 9/2. So this is 5 9s are 45/2. It is equal to 22.5 units.
In figure 1.81, the vertices of square DEFG are on the sides of triangle ABC. Angle A is equal to 90°. Then prove that DE square is equal to BD into EC. Now hint, here it is show that triangle GBD is similar to triangle CFE, and you have to use GD is equal to FE is equal to DE. Now solution. Now this is a first triangle, this is second, and this is third triangle, right? So clear cut, we have to show first triangle similar to third triangle. So for this purpose, first we need to prove first triangle similar to second, first similar to second, then second similar to third, then we'll from 1 and 2 will show first similar to third. Then after writing it in upon form, we will get the answer. So first we'll solve first and second triangle. So before that, we have to write certain points, that is quadrilateral DEFG is a square, right? If it is a square, so this 2 will be 90°, right? Therefore GD is perpendicular to BC and FE is perpendicular to BC. Reason, you all know each angle of a square is equal to 90°, right? Now we'll take first two triangles. Also one more thing, that GF is parallel, yes or no? GF is parallel to DE, right? So therefore we can take corresponding angles, right? So corresponding angles will take these two angles, right? So angle AGF is congruent to angle GBD. Reason, corresponding angles. We will give this as equation number 1. Also here from the right hand side, these two angles are also equal. Therefore we can write here angle AFG is congruent to angle FCE. Same reason, and we will give it as equation number 2, right? Now we'll take first two triangles, right? So in triangle, and we already know that we have to write everything in 1-to-1 correspondence. So I am starting from AGF, that means A 90°, G is alternate angles. So AG, not alternate, corresponding angles. AGF, and triangle from 90 is D, then alternate angles is B, and then it is G. So in triangle AGF and triangle DBG, first angle AGF is congruent to angle DBG, reason from 1. Then we will write 90°. 90° is A part, from here it is D. So angle GAF is congruent to angle BDG, reason each 90°. Therefore triangle AGF is similar to triangle DBG by AA test for similarity. This we can write as small equation number 1. Similarly, we'll solve second and third triangle. But here also 1-to-1 corresponding, and we have to take similar way AGF, right? So in triangle AGF and triangle, so 90°, here 90° is E, right? Next is G. G we are not taking, why? It is for it, we had taken it for the other triangle, right? So G is useless, that means nothing use. So here we can take, instead of G we can use F, right? And next is for F, we know already it is C. So students, always keep it in mind, it should be in one-to-one correspondence and these two triangles name should be same. So it would be easy to show triangle first similar to triangle third. Now we'll prove this. So angle AFG is congruent to angle FCE from 2, equation 2. Right, next 90 degree will be showing, that means A angle and here E. So GAF is congruent to angle FEC, each 90 degree. Therefore triangle AGF is similar to triangle EFC by AA test for similarity. This we can take as small equation number 2, right? So now these two triangles are similar, right? So we can solve like this from equation small 1 and equation small 2, right? We can write as triangle DBG is similar to triangle EFC, right? So now we'll write it upon form, right? So we can write as DB upon EF is equal to BG upon FC is equal to DG upon EC, right? Now we can check the question. What we need to prove is DE square. So we cannot find here DE, right? Next is, we will write here first DE square is equal to BD into EC. DE square is equal to BD into EC. This we need to prove, right? So here BD is given, yes, BD is given. EC, yes, EC is also given. So thing is only DE is not there, right? So this part we won't be writing. Therefore, and here reason we can write as corresponding sides of similar triangles. Therefore, DB upon EF is equal to DG upon EC. So in the next step, we can write as DB will be as it is. Instead of EF, we can check out in this is a square, right? So instead of EF, we can write as DE, and instead of DG also we can write as DE upon EC, right? So what we can do is we can cross multiply. Therefore DE square is equal to DB into EC. Also here we can write reason as quadrilateral is a square, therefore all sides are equal. What is quadrilateral's name? It is DEFG, right? So DE is equal to EF is equal to FG is equal to GD. Yes or no? So that's why instead of EF we wrote as DE, and instead of DG we have written as DE. So after cross multiplying we got the answer. So this is hence proved.